Okay, we have here the first thing before you go deeper into your counter. Before you go deeper into your counter, you need to know that counter can be divided into asynchronous and synchronized. And how basically you can differentiate these two counter. So the very easiest way, I go first at the specific slide. The very easiest between asynchronous and synchronized is synchronized are having the clock with the same source. Example, if you have only two, okay? When you have two flip-flop, okay, this is just a normal flip-flop that you can have for your JK. And remember, this is the symbol for your clock. And if I have like this, it means that it is a positive age, positive clock. And of course, I'm going to have like K and J here, 0, 0, F, F, 0, F, F1. Why is here if 0 and here is 1? You're going to start the first connection for your clock. You need to start with LSB until your MSB. If you still remember your numbering system, you have like 0, 1, 1, 0, 1, 1. This is your MSB. This is your LSB. Best 2. Okay, starting from this, if let's say you have a normal number like my favorite number 197, this is my LSB. This is my MSB. So this LSB will start at the beginning. And then you're going to connect, cascade until severals. From left to right. But for your numbers, you're going to write like this. Following LSB until MSB. Now you have here, about the connection, you have here Q. Here is Q bar, 0, 0, Q1, Q1 bar. And let we proceed with our connection. When you can have the synchronized, mean it is same source for your clock. So this clock here will connect to the similar clock at the beginning. At the beginning, it's going to be similar. Similar if you have another clock, you're going to connect. Another clock also, you're going to connect together. Because it's going to be from one source, one clock. While if you have the unsynchronized, it will be from different source. How the different source? For counter, you're going to have the source from previous Q or Q bar. So this is the clock you will get. Let's say I have like this, J and K here. This is my first clock. My first clock will directly connect to my first cycle clock over here, normal clock. And you have JK. And here JK, FF1, FF0, 0, 0, Q0, Q0 bar. 1, 1, Q1, Q1 bar. Okay, my clock here not going to be continuous and connect to similar source, but instead I can have like this. And I have also possibilities to have like this. It depends, the connection later on is depend whether it is a positive clock or negative clock and counting up or counting down. There is a table later on I want you to remember. But for starting from now, you can see if you have the unsynchronized, mean you have different source. This clock and this clock are different. Later when you have another F flip-flop, this flip-flop will be connect to this like this. So this one is different source with this. You can see because this is the source for your flip-flop one. Q1 will be your clock for your FF2. Similar if you have Q2, Q2 will be the source for your FF3 and etc. Okay, so this is the first thing I want you to know, which is about unsynchronized and synchronized. What is the difference between each other? Is same clock and different source. Sama lah, it's source and also clock. So the source for the clock is different for the unsynchronized and same for the unsynchronized. Next, what you need to do, both categorized can be differentiation. You can see clock trigger, whether it is a positive or negative age. Counter, binary indicate, later you're going to see this one. And lastly, count direct up, down or up and down. Example here, when you have a counter, you're going to calculate 0, 0, 0, 1, 1, 0, 1, 1. So this is your counter when you have the move like this. From 0 to 1, from 1 to 2, from 2 to 3, from 3 it back to 0. You can see the flow is going up. You can also have the similar view, but the arrow is pointing reverse words. It's going to be from 0 to 3, 3 to 2, 2 to 1, and 1 to 0 is called as down, counting down. But when you have both, you can have both, which is up and down using this count direction. Okay, you can read and go through this one. Which is apply also similar to your other type of flip-flop. Okay, this one is just a recap for you to still remember about our flip-flop. Last time we have the sequential circuit, then we get the flip-flop and also latches, right? Now we go deeper to our counter. Counter is any sequence circuit that goes through a prescribed sequence of states. So you have a sequence of state over here upon the applications of input pulse. So it's depend on the clock. Okay, the sequence that in a counter may follow a binary count or other sequence. You can have the binary sequence if you have 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. This is following sequence from 0, 1, 2, 3. But in this example, you can see here you are from 0, 1, 3, 2, 6, 7. This one is not 6. 4, 5, 6. Yes. This is 5. This is 4. This is 0. So you can see you can also have other sequence. Okay. Both can happen, depend on you. Sometimes if you go further after this, you can also having not go to the next state. You can see here, this is state number 1, let's say. State number 2, you can see it moved to another state. Okay, this error are showing that it moved to this state. If you have this error, it says that this is moved to this state. Okay, later you're going to have like this. If you have the scenario of 1 and 0, you can have like this, which is moving up, isn't it? And you can also have there is two state over here from 1 to 0. It's going to down. But you can also have goes up and goes down with the condition. When you have the input of 0, 0 will be go to 1. If you have the input of 1 for your 1, you're going to go to 0. Let's say, okay, this is one output. And maybe you can have over here, this is one input given 0. But when you have 1, from 0 it's going to maintain 0. From 1, maybe you have the input of 0, you're going to go to the same state. Let's say in the table, you have currently at state number 0. Next state is if you have input 0, you're going to go to the next state of 1. If you have the input of 1 for the state 0, you're going to remain 0. This is your next state, okay? After that, if you have a state 1, if you have input of 0, you're going to remain 1. If you have input of you are at the state 1, you have input of 1 here, you're going to go to the 0. So this is the view. Also that there is a possibility later on you're going to learn on this state diagram. Okay, but I just give you example what is the point of this error, which means that from one state to another. Okay, I need to accept your friend. Okay, I'm continue. Okay, the input pulse, this one is related to your code pulse. This one you can easily understand it. Then about a counter, you are moving the value, and normally a flip-flop that going to be used in counters will be JK flip-flop, T flip-flop, and D flip-flop. Okay, there is use of counter, where you can apply counter. Last time, if you still remember about your project, you need to think about your project related to any scenario. You can come with scenario of your parking lot. I already mentioned, right? So here is the example. If you have the parking lot, I inform that this scenario is you are the one that decide your scenario. So in this example, let's say you have one parking space here, and all together you have like 200 space parking lot. There is a lot of parking lot inside your space area. This is maybe level 1. Maybe you want to look into a level 1 only, the very basic. But if you want to compare and look into a specific level also, you can, okay? Depend on the scenario. I give you level 1 only. So this is your entrance. This is your exit. And you have the sensor there, entrance sensor. And then here the exit sensor. For starting, maybe you have 200 parking space. So how about maybe you can go and put the display of the parking level 1. So it is 200, let's say. And the display is going to be extra also for you to put. And about the counter, when there is a car moving into your entrance, it's move inside. So what happened? You're going to count up using your counter. It's going to trigger and your counter will count up. So here we become 1. So when it's count 1, you need to compare later on, feed it your output to your comparator. Whether the value of 1 is more or equal with 200, because this is your maximum number of space, right? 200. You compare with this, more or equal or less. So if let's say it less, it's going to go here. And you're going to compare how many. If let's say here, then maybe you're going to do the another circuit for you to deduct 200 minus 1 with the counter. So compare the value, maybe 200 minus 1, you're going to get 199 for free space. And this maybe you fit at your display here. Or maybe you can put your display at the free space. This is the display 199. And then there is another car coming in. So there is 2 cars already. It's going to count up. And count up, we compare again. Compare. Where is the answer? Is it more or equal? If it is similar, like 200 car already coming in, you're going to come up with full. Sini akan jadi full. But if you compare it is less, then it's go here and you're going to display, compare first, deduct with the value of your counter. You're going to get the display. If suddenly, if you, let's say you already have full 200, then there is 1 car coming out. So this car are coming out, and then it's going to go there, and your sensor will be countdown. It will detect at your exit counter, and it's going to count down, means that let's say it's from 199, it's going to count down to be 198. And let's compare this one to be into your comparator. Is it more, equal or less? Then you compare with your maximum number of space and you display it. So this is the purpose, one of the purpose of your counter. Of course, using your counter, just single one, you cannot come out with the system. But you need the counter to compare at the beginning side, to calculate at the beginning side. Next, where else you can use? You can use in terms of the digital gate. Let's say you have this gate A, and this is gate B. You're going to count. Let's say over here, there is a car coming in at these sections. Let's say start at 5 seconds. Or maybe 5 p.m. And it's going to be automatically open after you count until 30 seconds. Then automatically gate A will open first. After another 30 more seconds, suddenly the car can move along after they count up to 1 minute altogether. So this is just example. The scenario, as I mentioned, is depend on you. And another one on the bomb here. You have the bomb here. For this example, if you press the button or maybe you're going to pull the trigger, then it's going to start counting 0, 1, and then 2, 3, until it goes to 20, 1, 0, 1, 0, 0. This one is 1, 2, 4, 8, 16. So after you reach this state, then you're going to stop, and it's going to result to bomb. Okay. After that, you can also have to generate clock to different frequency. By dividing the frequency, we can get a different clock frequency. So you can see from the same source. Okay. Now we go deeper for our counter. Just now is all on theory where you're going to apply, why you need to learn on counter, what is basically the counter. Over here, we're going to go and take a look into characteristic of counter. You need to find out whether your counter is unsynchronized or synchronized. And then counting sequence, whether you are going to count up or down, or maybe both, or maybe it can be a random. Say from 1 is count to 7, from 7 is going to count to 5, for 5 is going to count to 12, let's say. So it is a random. While then next you're going to have modulus mode at the end of this topic, or we can known as transcaded or full. And lastly, whether the counter repeat the counting sequence or not. If it repeat, it's going to be a recycle, and another one is non-repeated, it's going to be saturate. Here, the thing that I already showed you just now, if it is synchronized, it's going to be same source. If it is unsynchronized, it's going to be different source. So look at the proper picture here. You have this clock. Okay, this clock are connected to one clock only. Means that it's similar clock. Called as synchronized counter. And next we have similar things, but you need to know this is your JK0, JK1, JK2, and JK3. So your digits coming out also, you need to know this is Q0, Q1, Q2, Q3. Why this happened? Because now our clock are here. We will start at the beginning of flip-flop connected to your LSB. Just remember that. Now we have in terms of the direction, the second objective about your characteristic here. You have the counting section, whether it is up or down, whether it is having a vice versa. So for this example, what happened? You can see it's going to similar side or similar view. We call it as unidirection, only one direction, one way. Second, also you have the unidirection. And lastly, for the third example, it is a bidirection. You can go from state 1 1, you can go for 0 0, you can go for 1 0. From 0 0 here, you can go to 1 1, you can also go to 0 1. Okay, and counting up, of course, you're going to repeat your numbers. For this example, you're going to repeat from 0, 1, 2, 3 until you meet the maximum is to the power of n minus 1. What is n? Is your bit number. Let's say you have to the power of 2, 2-bit number. You're going to get 3. That's why you have only 3 sequence. And then after that, for the third one, it is on your modulus mode. The number of state that the counter can have. Example, as let's say your counter are having 3 state only. So you're going to have mode 3. If you have another 2 more state, we will have it as mode 5 and etc. And under your modulus, after that, you're going to look into whether it is a repeating sequence or not. If you have repeating, it's going to be recycle. And if you have saturated, the counter repeat the maximum count if the count up, or repeat the minimum if the count down. Okay, let's take a look into the example, how the connection look like and what this connection can be coming up for. Okay, here you can see we have unsynchronized counter, or we call as AC. And AC is one which the flip-flop within the counter do not change state or exactly the same time, because they do not have the common clock pulse. The clock input of SC is always connected only to the LSB. This is the thing that I just mentioned. You're going to start at the first side here, must be LSB flip-flop. And SC also known as ripple counter, where you're going to apply this question. This one is normally been asked in your part A. Sometimes you said like, what is asynchronous counter? It is also similar to ripple counter. Okay, next here, we're going to see the differentiation, similar, repeat again on the synchronized and unsynchronized. This is different source of clock. But for this example, you are having the similar clock at one time. Okay, this is this is the important about your unsynchronized counter JK flip-flop. You need to know about this. The asynchronous counter is slow because the cascade looking scheme. From this to here, from this to here, from this to here. The clock source ripple the state to state. The clock effect is similar to the ripple carry at the circuit. Okay, this is a table. I want you to remember. First thing, you need to look into positive edge only. For positive edge, this is my circuit. This is my circuit of my flip-flop clock. Positive edge, and then you need to come up with your counting up counter. You need to connect your next flip-flop to your previous Q bar. Second, when you have positive edge, you're going to count down, going to connect to your Q as the counter. And then for the negative, it's slightly easier, similar, but it vice versa there. For negative, you're going to have that bubble thing. And for your counting up, you're going to connect to your Q output from your previous FF. You can see here also for your FF is similar. And then you're going to connect to your Q bar. This is the connection for the very beginning. It's important for you to do and to understand. Okay. Now I'm going to show you example of 1 and 2 bits of AC. Okay, because I want you to do a Jamboard later on. You can see the connection of your clock to your LSB, and then the previous FF come from previous FF. Each of flip-flop going to get from the previous. Now let's see this example. This is the count up positive edge. Okay, I look back. Positive edge, count out. Your input for your next flip-flop going to connect to your Q bar. Okay, that's why you're going to have this connection. Let's play around with our Q. The initial Q is low. So this is our Q and it start with low. We look into this flip-flop only similar to your JK flip-flop. JK 0001 1011. You have what over here? Your Q. 00, no change. 01, reset. 10, set. And lastly, 11 going to be toggle. For this side, remember here, you can see the J and K are always connected to this 1, 1. So that's why later on after this, when you have the trigger at the positive clock, you're going to toggle. Say here you have this clock. This clock you can draw it by yourself. It's very easy. And for Q0, it's going to depend on this. I will going to trigger when I have positive edge only. Positive, 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 positive. I'm done with this. And then after that, I'm going to start with 0. Low, when I meet my active high, I'm going to look into my input of your JK. Now my input JK is always 1 and 1. Then I'm going to do the toggle from 0 to be 1. And I continue until I meet another positive edge. It's going to be toggle. So it's going to be toggle. And then from here, I meet another my positive clock there. I'm going to toggle. And lastly, I'm going to toggle also. For this side, because, okay, now I already done this. I already get the Q0. This is my Q0, right? Now my next clock, my next flip-flop here, I need to connect the flip-flop. Without flip-flop, I cannot manage to run my output. So this is my clock. Now I need to connect to my Q bar of 0. That's why I'm going to draw my Q bar, which is toggle from all under Q. So from this Q0, I'm going to toggle everything. So I done for this clock. Now this clock will get the value of Q bar. So the clock, what happened is going to assume to be 0, and then there is a positive, and then there is be a positive clock only. We're going to trigger to be what? Toggle. Now at this, I already draw the timing diagram. Now I'm going to plot it with the value. Okay, this is the value of cycle 1. Cycle 1, I'm going to look into, it's going to be 1 and 0 here. Cycle 2, 0 and 1. Cycle 3, 1 and 1. Cycle 4, 0 and 1. So I'm going to come out with my table there. This one is already finished. I get my Q1 already. Q1, Q0. And then I have my value of cycle. Cycle 1, cycle 1, cycle 2, cycle 3, cycle 4. And then I have the initial value. Initial, it will be 0, 0. And then it start here 0, 1. 0, 1. 0, 1. And then from down to up, it will be 1, 0, 1, 1, 1, and lastly it's going to be 0, 0. If you have 5 here, you're going to get different. Okay, so then you can see this one is continuous with each other. That is your table. After your table here, you're going to draw your stat diagram. Okay, where this is example of your table. Now you're going to draw your stat diagram following your counter. So what happened? You're going to have 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. From here, you can see the move from 0 to 1, from 1 to 0, from 0 to 3, and then from 3 is going to go back to 0. This is your stat diagram. This is your stat table. That is this only 3 things that you need to remember. So I'm going to give you another example for a 3-bit counter. But for this one, wait, it's already 2:45. Before we go to this example, I want you to conduct your mana pen saya? Okay. Using your lab group, if you group 1, group 2, 3, and etc., follow your own group. Draw the logic symbol. Draw the 1, 2, 3, 4, 16 clock clock cycle. Conduct the state table, and lastly draw the stat diagram for your question here. Wait, the question is 4-bit 4-bit. I want you to discuss with your friend. Go to the link. I'm going to give you the link. I'm going to share here. Okay, go to the Jamboard and then pick your space. Normally you're going to use 2 space if you draw too big. You draw your group number. Let's say you are from group 1, and then what is the team member name, and do the 4 things. First is your logic diagram. Second is your timing diagram. Third is your stat table. And lastly, fourth is, kenapa tak gerak punya apa ni? Fourth will be your stat diagram. Okay, so you have 4 things that you need to do. Macam mana I nak balik ni clear frame? So pick your frame, pick your workspace, name your group, and then you're going to draw the 4-bit positive counter up. If you are odd, group 1, group 3, group 5, you're going to draw 4-bit positive countdown. For the even, you're going to draw 4-bit negative edge counter up. Okay, so please try to discuss now. In meanwhile, after this, I'm going to share later on our bit 3, and then I will redo again your counter up bit 3 and so on, so that you can understand. I want you to do now because I want you to learn with your friend, then you can understand it carefully. Okay, start now. Wait. Yang negatif kena buat dalam ni. Negatif kena buat dalam ni. Bismillah. Okay, if you have any question, you can ask me. Oh, tanya dekat chat pula dah. Alamak. Saya buat salah ke? Only, right? Create only. Finish, create only. You need to come up with 4 logic diagram, and then timing diagram, stat table, stat diagram. Okay, group number group number 1. Where is your table, stat table and stat diagram? And then, number 3, group number 3, sorry. Group number 3, your table and stat diagram. Group number 4, stat diagram. You orang ni pandang, padam-padam tiba-tiba hilang, tiba-tiba muncul ni. Macam mana dia? Ya, I refresh dulu. Group number 1, you still didn't do your stat diagram. Group number 3, timing diagram and stat diagram. Group number 4, stat diagram not yet. Group number 5, table and stat diagram. Group number 6, table and stat diagram not yet finished. Group number 7, table and stat diagram. Group number 2, just doing the logic diagram. Okay, can you try to speed up? You can draw in your paper and then just upload the picture. Okay, group number 4 already finished. Group number 4 leave. The rest is not yet finished. Team number 2, hurry up. Boy, group 1 dia kata compare dengan group lain. Mana boleh meniru? Siapa yang tulis ni? Nak compare-compare pula. Buatlah sendiri. Yes, yang kita buat negatif. Ha? Aduh. Group lain macam mana nak tutup ni? You punya jawapan. Nanti group 1 tiru. Dia dah bagi tahu dia nak tiru tu. Okay, finish or not? Everyone? I hope that you can finish. Okay, I hope that you can finish as another 5 more minutes. Can or not? Group number 4 already finished. Tapi kenapa you still drawing? Oh, maybe you want to do the dotted line. And group number 5 still trying to do the table. Group number 2. Okay, number 2 just done the timing diagram. 5 more minutes. Maybe you can just draw in your paper and then upload it. Send picture. Group number 1. Okay, I'm going to comment for those who already finished. Siapa yang lambat, those who late, you need to explain. So it's better for you to hurry. Hurry, draw and upload into your Google Jamboard. Okay, I'm going to go for group number 4. Where is group number 4? Group number 4. Okay. Now I'm going to share my screen. Okay, now we have here group number 4 answer. So let me mark and give my comments. Here we have first thing for your Allah kena. Okay, let me refresh first. Okay, first thing what we need to check is on our flip-flop. Whether our drawing is correct or not for this, which is your block diagram. For your block diagram here, I can see you have 1, 2, 3, 4, and it's follow the sequence is correct. And your group number 4, you should do the negative edge count up. Negative edge count up. And the others connection is correct. You can see all are connected to their high. And then for the first clock here is connect to the clock. And I can see all the bubble thing refer to the negative edge clock. And then about the counting up. So how the connection go to your specific last time? I asked you to remember. For positive, negative count up. So you can see you connect to the Q, previous Q. Okay. Now you can see here, this is all correct. In terms of the connection, in terms of all the labeling. And I'm going to go to my to the timing diagram. For the timing diagram, kenapa dekat belah kanan? Supposedly selalunya belah kiri, the labels. But it's okay. It's better for you to help your lecturer by drawing like this. 1, 2, 3, 4, 5, 6, 7 until the end, which is continuously. And for each of the specific line like this, you can see if at the cycle 1, your value will be like 0, 0, 0. So I can see. So help your lecturer while marking your answer script. Okay, so put the value. But I believe it is correct. I can see that you are toggle at the negative clock here. And everything is at the negative clock. Yes, here also negative clock, here also negative clock. Okay, now we move to the state table. For the state table, initially it's 0, 0, 0, 0, and then you start with 1. For your clock 1, see your answer is wrong because you just draw the table without referring to your timing diagram. You can see here at initially at your cycle 1, it is 0, 0, 0, 0. At your cycle 2, it is 0, 0, 0, 1. So you can see here your cycle 2 is already moved upward, which is 0, 0, 1, 0. So your answer is wrong. See, because you just draw, you just notice that, okay, of course lah, the answer will be like this because it is counting up. Using your logic only, then you draw your state table. But if you're referring to exactly the place here, your answer is wrong, okay? So please make sure you draw the timing diagram. After your timing diagram, you check all the output at the specific cycle. Then you draw your stat table. If not, you can see now your cycle is all already different for each other. Then it's going to be incorrect, okay? Now for your stat diagram is correct. I can see the flow from each other and it continues. Okay, let we go for group number. You change ah? Let we go for group number 1. Kita tertutup dah. Macam mana ni? Nak I tolong padamkan? Okay. Habis dah. Now, let's check the block diagram here. Your question is positive count. Positive countdown. Tadi beria sangat lah ikut kawan dia cakap, kita buat negatif. You buat odd number kan? Odd negatif, odd ganjil ke genap? Saya dah sampai confused dah dengan awak punya soalan tu. Odd ganjil ke genap? Hello?
Ganjil.
Ganjil kan? Siapa yang tak tahu odd tu? So your answer dah salah dah. Siapa yang ikut kawan you tadi kan? Ni negatif lah. Yes, negatif lah. So supposedly the question for your group number 1, you number 1 means ganjil. It is odd. So odd will be doing a positive count. Dekat sini je dah salah dah. Positive, there is no bubble thing, okay? So positive supposedly is going to be like this. That is the only difference I already mentioned just now in the beginning of our class. Negative got the purple here. Siapa yang buat tadi Asyik tanya soalan tu je saya nampak tadi. So this is wrong. And after that, let's check your timing diagram here. So your timing diagram, kejap I go back to your group number 4 just now. Okay, group number 4, they draw the error, so it's okay. I lupa nak check yang itu. Okay, group number 1, go to the timing diagram here. You can see this is the clock. Okay, please label it so that your lecturer knows. And kenapa you start daripada 1? Kenapa you start daripada 1? What is the reason you start daripada 1? Normally our previous Q we assume is to be 0. But it's okay, mungkin you nak assume daripada 1, but it is rare to be happen like this, okay? Okay, now we have count up. We have positive. So you need to draw at the positive error. Kat sini you punya timing diagram, you buat toggle dekat positif, tapi you punya block diagram ni salah. So it's better for you to draw also the arrow, help your lecturer to understand what are you doing right now. So you know that okay, this is a positive. Then after that you can see normally counting down, okay? Normally you're going to see at the cycle 1, what is your answer? So here let me see your cycle 1. Ni pun sama dah salah, buat suka hati je. Ni, this is your cycle 1, okay? This is your cycle 1 because you already mark it as a cycle 1. Your answer supposedly 1110. Let me see your stage 1 here. Why it is 000. Siapa yang cakap? Tadi I rasa ada orang tulis kat sini senang sangat. Grup ini ke yang cakap senang sangat buat stat table dia? I dah tak ingat dah grup mana. Tapi itulah set table asyik salah je ni sebab you tak refer langsung pada kat you punya timing diagram kan. Dari mana pun saya tak tahu. You meniru lah ni kiranya sebab you tiru jawapan daripada tempat lain. Okay, daripada Norway you terus dapat jawapan answer dia. Okay, if you refer to here because your starting is 111 so semua dah berlainan because if you are starting at 000 jawapan you lain, if you starting at 111 you're going to have different because you're going to toggle at here, right? If you start at 0 it's going to be 1. So now you are assuming it's to be 1. So I'm going to refer to your assumption because I tak cakap kan initial Q0 is what. So now you assume it's to be starting at 1, then you need to follow lah why you do like this, okay? So here your answer supposedly 1110. At your cycle 2, 1101, ini pun dah salah. So everything is salah here, salah here. This one okay, I can assume lah because you assume is to be 1. Okay, I give you 0.5 mark. Next is your stat diagram. Kenapa macam ni? Pusing ke kiri pula. Okay, tak apa, kita tengok jawapan dia betul ke tidak. Siapa yang suka terbalik ni? Selalunya kita akan buat macam ikut bentuk clock tau. Tapi tak apalah, asalkan kita nampak dan kita faham. Okay, kita akan follow anti-clockwise. Bolehlah juga acceptable as long as your answer is correct. Let me check here. Because there is no starting point, normally it's always correct. From 1111, it goes to 1110. And then after that, 1101, 1101, and followed by 1110. And through the lastly 000. And then it continues to be 1111. So this one is also correct. Mark for 0.5 only because you cheating dari awal lagi you nak pergi tiru kumpulan lain. Okay, evidence dah ada tadi, I dah sempat dah tengok. Okay, next group. Group number 3 here. Okay, we have, you dah siap ke belum ni? Group nombor 3 siapkan sekarang. Mana you punya table? You punya table dengan you punya stat diagram. Kalau you tak siap, I suruh you explain I pergi kat group lain dulu. Okay, group number 5 here. Okay, let's check the block diagram. You do the positive, okay. Correct. Okay, hi. 1, okay, it is from LSB to MSB, also correct. Everything is correct here. And move to your, apa ni? I tengok je, I dah marah dah. You are doing a positive. But suddenly dekat bawah ni, you jadi negatif pula. Okay, I already inform you for the, Allah, kat mana yang lukis? For the clock here, you have, if you have positive clock, the arrow should be like this. Although I already inform dalam kelas, although you can see, you can put here because it is one way, right? But this only for negative clock. You cannot have two in one clock. In one waveform, you cannot have up and down. You need to only follow whether your clock here is positive and negative. Now your clock, alamak saya terpadam dah. Now your clock is positive. You need to draw the positive side, not this. So your answer is wrong, okay? You also trigger your toggle at the negative side, so wrong. So I don't want to check your answer. It is totally wrong. Okay, so please make sure and carefully next time, but it's okay. You're going to learn from your mistake. So kawan-kawan lain don't follow this thing, okay? Please make sure you remember in terms of the symbol, in terms of the representation, where you're going to trigger. It's depend on positive, it's going to be positive clock. If negative, you're going to trigger at the negative clock. And of course, your timing diagram, how to check because your answer is wrong. Tapi I know that most of you just copy paste the following sequence, but it's wrong. Here, okay, this one is your state diagram. You're going to start at 0, 0, 0, okay, and then after that you move to 0, 0, 1 supposedly, but you can see your answer here. Now you have at cycle 1, 0, 0, 0, 0. At cycle 2, it is 1. It is 0, 0, 0, 1. Cycle 2. But this one is wrong. Okay, you follow sequence, it's correct. Okay, now I go back to group number 3 just now. Oh, tengah. Crop lah. Crop lah jawapan tu. Tak boleh crop ke? Okay, I go for the next. Group number 6. Okay, group number 6 already finished. For block diagram, negative. Negative is correct here. We connect to the Q. This is correct symbol. We connect to the high and we connect to the clock. Everything's correct and follow the sequence from LSB to the MSB. And then next our timing diagram. For the timing diagram here, you are doing negative. It is correct here. And for this part here, okay. And for this part here, you are changing and trigger at this correct place. So let me check your value of cycle 1, 0, 0, 0, 0. Cycle 2 is 0, 0, 0, 1. Let's check your table. 0, 0, 0, 1. You tukar cepat-cepat waktu I check 0, 0, 3, cycle 3, 0, 0, 1. 1, 0. Correct? Mana ada. Yelah tu. Ada bukti tak menyatakan you dah buat dulu ni? I tak perasan tadi. So cycle 4 we have 0, 0, 1, 1. Okay, correct. So it is here also correct. Tadi yang cepat tadi betul Group number 5 kan I check awal-awal. Oh tak. So group number 3 only that got correct for all. Yeah, jujur. Okay, now you can see here you are doing the counting up. So this sequence is correct. So everything is correct. Lastly, the group number 7. Let's check the answer. We have the positive. Just now, group number 6, negative. Okay, group number 6 only get 100 per 100. So, I bagi bintang dekat sini. Berapa bintang lah? 3 bintang. Next, we move to group number 7. We have here, okay, correct. This one is correct. Clock, clock connection is everything is correct and follow the sequence from LSB to MSB. Now, salah. This is also negative. Siapa buat ni? So salahkan kawan you. Tadi group number 6. Okay. Group number 7 also salah. Itulah tiru kawan-kawan kan. Jom kita tengok sebelah, jom tengok sebelah. Inilah jadi dia. This is also negative. I tak nak check, salah. Totally salah dekat sini. Walaupun you punya table betul ke, ni mesti tiru group lagi satu ni, sama juga. Ke belakang juga ada punya pusingan tu, tak apa. Okay, here we have the follow sequence untuk ke counting down. Kita tengok the initial, you can see cycle number 1. Cycle number 1 is all 000, tapi dekat cycle number 1 dia 001. Kat sini pun dah salah, it's already wrong. Cycle number 2 0001. So here is 0010, kat sini pun salah. So you need to refer your timing diagram to plot your stat table. Okay, this one group apa ni? Group number 2. Oh, group number 2. Tadi yang tak siap tadi group number berapa? Number 2 lah Group number 3. Group number 3, you punya timing diagram you still not yet upload. Okay, group number 2 here. You have negative. Okay, negative. Ni macam baru taruh je ni. Warna biru ni. Macam salah je ni. Okay, negative. And then you connect to clock and then high. Follow the sequence from LSP to MSP. So correct. And then negative here is also correct. You're going to trigger at the negative side. Yes, yes. So in your final exam, please help your lecturer by putting all the dotted line, including the value inside. If you have like cycle 1, you put the value 0000. Cycle 2, 0001. Cycle 3, what is the value, okay? So then your lecturer will compare the answer easily. Next is your straight table. Okay, correct. Your stat table also correct. And this one is most the easiest. So this is also correct. Okay, lastly, group. So we have berapa group already get full mark? Group number 7. Salah tadi kan? Group number 4 and number 2 got also 100%. Okay, last group. Okay, this is the group number 3. Group number 3 supposedly to do the positive countdown. Okay, this one is correct. This is connected to KECIL. Correct. This is follow the sequence from 0 to MSB. All the connection of your JK is correct to the high. You can just connect to one single line there. And for the connection of the Q to the next is also correct. But salah juga ilmu ni. This is negative. Semua sama sebab semua meniru sesama sendiri. Negative clock, it is all wrong. Supposedly it's going to be triggered to get the wrong table. This one is easy, can get the answer. Let's recheck the cycle 1. Cycle 1 here will be 0, 0, 0, 0. Cycle 2 will be, because your answer is already wrong trigger, I just look into your answer. Here will be 0, 0, 0, 1. Cycle 1. Cycle 1 dah salah dari kat sini. Macam mana you dapat 101? 1101. Siapa buat ni table ni? Who did this table? selalunya walaupun you just tiru saja table you reka, tapi follow sequence. Yang ini dia tak follow sequence langsung ni. Daripada 0 you pergi ke 6, you go to 0 balik, you go to 4, you go for 4 pula. Sini adalah 1, 2, 4, 8. Kejap. Daripada 0 you pergi ke 8, 12. And then you go for 0. And then suddenly you jump to 8. And then suddenly you jump to 4, 6. Then suddenly you jump to... Lah, you buat terbalik ke?
Sorry doktor, salah baca.
Aduh, I baru perasan. Confused dah ni ha. You... Sekejap I nak tengok yang lain. Nanti semua buat macam ni ke? Okay, Q3, Q2, Q1, okay. Q3, Q2, Q1. Q3, Q2, Q1, Q3, Q2, 1. Ini pun sama, okay. Okay. Kenapa you seorang je yang buat lain ni? Aduh, mana tadi? I pun dah jadi confused kat sini. So, okay, saya tengok daripada sini saya kena baca terbalik Baru saya perasan this one is 0, Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3. 0, 0, 0 and then 1, 1, 0, 0. Mana you dapat? I macam tak pasti dah.
Sorry doktor, saya lukis buruk. Tu saya salah nampak.
You lukis apa?
Tak, saya lukis buruk.
Okay, tak apa. Sekarang ni saya nak tanya ni, flow ni berapa? Malah saya nak kira dah. Ni daripada 0 pergi ke berapa? Kejap. Tak apa, I berusaha untuk memahami sekejap. I try to check. Here your answer will be 0, 0, 0, 0. Ni 0. Here will be 0, 0, 1, 1. This one will be 3. And then here will be 0, 0, 0, 0. Pergi 0 balik. And then you have 0, 0, 0, 1. You pergi ke 1. Siapa yang buat ini tak sama pun dengan you punya table. And then you have here 0, 1, 1, 0. Sini adalah 6. Macam mana you punya jam tu? You refer ke mana? Aduh. Nak tanya.
Tak apa, baik. Saya salah faham.
Okay, so because we are counting we are counting which kita tak akan jump daripada satu nombor ke satu nombor yang jauh. You're going to calculate whether daripada 1 to daripada 0 ke 1, daripada 1 ke 2, daripada 2 ke 3. This one is counting up. Kalau counting ke bawah, it's going to be like start from 3, 2, 1 and then 0. But this is counter. Counter dia akan kira 1, 1, 1. Dia tak jump terus pergi from one number to another number, okay? So please make sure all of you remember that, okay? Then this one is supposedly correct. I hope that you learn from mistake. It's okay to do mistake. Now we have here everyone's already done. Okay. Thank you for your participant to do this Jamboard. Let me share our next example. Sikit lagi I buat example dulu For your example number 3 bits. Supposedly if you can do the 4 bit, for 3 bit, 2 bit, semuanya tak ada masalah. It's not going to be a problem. So you can see here, you have the similar loops. It's the different only whether it is a positive and then whether it is counting up mana positive counting up or counting down. So here is counting up. Okay, this is counting up. And you look into the connection. How is the connection from the basic? You just add another few flip-flop, another few flip-flop. And initial value is given here for Q0 is low, and normally it's going to be low for all. And starting from here, you can see as long as your connection, everything here is correct, then you need to draw your timing diagram. For your timing diagram, make sure help your lecturer, not me, not because I mentioned last time, I'm not the only one who marking your test or final exam, okay? Last test too, some of you contact me, inform like you forgot to put this answer. When you scan, there is no name, cut your half of your answer. I can inform other lecturer, but it's depend on them because I don't know who going to get your answer script. So please make sure for final exam you be careful, okay? So if you have like clock here, please help your lecturer and draw whether it is clock counting clock positive or negative. So this is positive, so you draw the dotted line like this. Maybe you can prepare a paper that having this line, the dotted line here. Later you just draw the wave, isn't it? So it's help you to speed up, prepare for your final exam. And then you can see here you are toggling at the positive. Why is all toggle? I already mentioned because this is connected to 1. For your JK flip-flop is 1 and 1 is going to toggle the value of your output. So it's going to be toggle at positive only. So the next Q will be following the positive also. You can see here positive, positive. But I think for this one, it's not that. Basically, it should be here. But for this question, it shares you. I think this one is wrong. That's why others lecture are putting it as height. So it will be like this, and then it's toggle and continues. Okay, then after that you see your cycle 1, what is the value? Cycle 2, what is the value? Cycle 3, what is the value? And until it follow the 0, 0, 0 and it reverse back cycle. Okay, so if I think if you already understand the 4 bit, it's easy for you to draw 3 bits. Whether it is a countdown or count up, it's all depend on your basic table here. I hope that you're going to try to remember this basic table because it's easy for you to later on to adjust, enhance. Okay. So any other question? Next class, tomorrow we're going to have our asynchronous ticket counter. Maybe you can try to do. And maybe you can look into this equation also. This is very important equation for your final exam. Of course, it's not going to give you direct question like what is maximum operation frequency. Instead, maybe you were given with the frequency maximum, you need to find the number of flip-flop. Then play around with the equation. Any question? I'm going to share the attendance QR code again. If there is no question, then you can dismiss. Thank you for your participant. Meet you again tomorrow. Okay? Bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Doktor boleh share QR tak?
Duluan.
Okay dah.